What's up, my favorite discussion? Um, this is going to be question number 8, so the last question. And this is hailstone tree. And so, yes, so the idea behind hailstone tree is that, we have the hailstone sequence, and the idea here is that, like, if it's odd, we're going to go, like, um, take that number, like, 3 times. I don't even remember actually. Yeah, so if it's odd, we're going to take that number and go like 3 times n plus 1. If it's even, we're going to multiply it by 2. Or, oh no, divide by 2. My bad. Divide by 2. And the idea here is that like we're going to keep on doing this sequence all the way until we get down to like the number 1. And so here, it's kind of interesting. So we actually want to generate a hailstone tree. And what does it mean by a hailstone tree? So we have like a number n, and then the height, when it like branches out, we're kind of going to like elements that it could have come from. So that might not make sense right now. Hopefully, also pause the video, take a second to like read through the doc test first by yourself, because it would be pretty helpful for you to understand it yourself in the case of like an exam. But yeah, let's get started. And so starting off, let's say like n is 1, right? And the thing about n is 1 is that there's only one place that it could come from a 2. And in the case of a 2, it could have come from like 4 or something like that. And that could have come from like an 8, and that could have come from like a 16. And if you might imagine, 16, 8, 4, 2, 1 is like a hailstone sequence. And so that's going to be one example. And another example that might be less straightforward is like 8. So this example right there. So 8 can go to 16, but then, as you can see here, it kind of branches into 2 different things. So 5 and 32. And so the question that you should be wondering right here is that, like, how did it branch into 2 parts? Well, the thing to know about like hailstone sequence is that like there can be 2 numbers that lead to the same number. So in the case of 5, since it's odd, it's like 5 times 3 plus 1 going to 16. And then 32, in the case of 32, since it's even, 32 divided by 2 goes to 16. So these 2 numbers, 5 and 32, both lead to 16. And note, the special thing that you really want to note about this problem is the fact that sometimes there's 1 branch and sometimes there's 2 branches. And so if we note, for like 8 to 16, there's only 1 branch. And if we think about it, is there really an odd number that's going to like lead to 8? So like 3 times 2 plus 1, that's 7. Well, 2 isn't even like odd, so we can't even count that. 3 times 3 plus 1, that's 10. How unfortunate. 3 times 1 plus 1, that's 4. So the reason why there's only 1 branch is because there's only 1 path that it can come from. So only 16 leads to 8. And so you might imagine that inside of your code, you're going to be having to like determine whether there are like 1 or 2 branches. And so hopefully that gives you like a sense of like what we want to put into our code down here. And last but not least, the other thing to know about this problem is that we have this h parameter right here, and it's the height of the tree. So when it says like the height of the tree, it says like, let's restrict the size of our tree to be like this certain number. So in the case of like maybe my height was 1, then 8 would go to 16. But I want to keep it at this height. I don't want to go like 532 because that would be a height 2 tree. So I just want to keep it at 8 going to 16. And that would be my final tree. So keep that in mind as you think about this problem. And like think about how you would change h for each recursive call. And also how you would change anything else, like n, for example. And so this is a pretty tricky problem because of the fact that like you're not like running tree recursion on a tree, but you're actually like generating a new tree. So this is actually regular tree recursion with trees added into it. So hopefully that idea made sense to you. Too tired to think, but yeah. And so take a few minutes to think about it, and then we'll go over it together. Yeah, and so the idea here is that like we want to be able to like create a new tree. And so let's think about like what recursive call we could probably do. So let's say we're generating this tree right here, 8, 16, 5, 32. And then we want to say, how can we make a recursive call to generate maybe this tree right there? So the parameters that we pass in are like 8 and maybe 2. So we're generating a hailstone tree with number 8 at the very top, and it's at height 2. And the question is, how do I generate this 16, 5, 32 tree? Well, yeah, so think about it for a sec, and I'm going to start now. And so if we do a call to hailstone of 16 and 1, the hailstone tree starting at 16 is going to lead into like the next elements that are going to be that lead to 16. So in this case, it would be 5 and 32. And then restricting its height to 1 is going to make sure that we keep its height at 1. And so it won't go into things like 10, for example, right there, like 64 right there. And so it's going to keep it exactly like that. And then you might imagine how this plays in with the final tree is that a height 1 tree, or like a height h minus 1 tree, combined with this like very top node label, it's like h minus 1 plus 1 is going to give us a height h tree. So that's why we want to decrement h. So our tree is going to go like that. And then these recursive calls are generating a hailstone tree starting at something that could lead to that element. So in this case, it might be, let's say the top was 8. And then the element that might have led to 8 was 16. And so if you make a hailstone call to 16, and then we say, give us a height h minus 1 tree, it's going to generate everything below there, and then we can attach that back to that 8 tree right there. Is there another way to explain this? Yeah, I guess I'm going to repeat myself, but overall, it's like the hailstone recursive call is handling like generating the tree for like one step forward. So 8 going to 16 is going to generate everything, all the hailstone sequences that lead from 16. And then its height is going to be h minus 1, because if we consider the total tree, this branch is going to handle h minus 1, a height of h minus 1, and adding that h minus 1 plus 1 back in, we're going to get a total height of h. Yeah, so that's the idea with the recursive calls. And the question is, last but not least, what we want to handle is 1, the base case, and 2, how to determine whether we have 1 branch or 2 branches. And so let's consider the base case. So let's say we are making a recursive calls like 4, 1, and you're making recursive calls, 8 leads to that 4, so we might make a recursive call to like hailstone tree of 8 and 0. And so what's going to happen here is that we're asking for a height 0 tree starting at 8. So you might imagine that like 8 is like branching out into some stuff. That's our hailstone tree. But since we're asking for height 0, we don't want to have any more branches because that would be like height 1, and we don't really want that. And so what we can do with our base case is that we can just return that tree as like a label, like a leaf. And so in this case, if the height that we want is 0, then we're just going to return a tree with just that value as a leaf. And so second, we want to determine how many branches we can have. And so let's consider like the even and the odd case, whether each branch could have that number. And so the thing to know about even numbers is that it's always possible. That branch is always going to exist. And so considering maybe like 8, the number 2 times 8, or like whatever number that you have, that number is always going to lead to back to 8. Because if you consider like 2 times n, and like it will always lead to n due to the fact that 2 times n is even, and following the rules of hailstone, 2 times n divided by 2 would become n. And so we're good to go. And so 2 times n is going to be always going to be a branch of this hailstone sequence. So the even number that leads to that number, for example 4, there's always going to be that 8, or that 2 times n that's going to lead to that 4. And so that's one branch that's always going to exist. However, we need to consider the odd number. And so it's not necessarily true that any odd number, like there exists a number that's like 3 times n plus 1. So we're trying to solve for the fact that like we have a number n, and we want to determine if there's a number maybe x, where like 3 times x plus 1 is equal to n. And note that we want x to be like an integer, like an actual number. We can have it be like 3.333 or something like that, because hailstone doesn't deal with that type of stuff. And so let's solve this equation right here. So x is going to be equal to n minus 1 over 3. And then so what do we want to know about this? Well, we want to make sure that n minus 1 over 3, there are two things that we want to make sure of. And so think about what we want to make, like, ensure. Take a minute or something. But yeah, so two things that we want to make sure is that this is 1, an integer, and that this is also an odd number. And the reason behind this is that first, I talked about it earlier, but x has to be an integer. Due to the fact that like hailstone sequences only deal with integers, or like numbers. But the other reason is that we want to make sure it's odd. And so the reasoning behind this is that if I had like maybe 7, you might be imagining that it goes to 14 and also comes from 2. But the thing about this is that 2 is even. And so remember, like the rule for hailstone is that you have to always divide by 2 for an even number. So 2 actually leads to 1, not 7. We can't do like times 3 plus 1 because 2 is even. And so that's why we want to make sure that n minus 1 over 3 is odd. So those are the two rules that we're going to make sure of. And you can imagine that when we're checking this condition, this if block right there is probably going to be checking if like we can actually add an odd number in. And then over here is the case where it's always that even branch is always going to exist. And so yeah, let's get into our code once again. And so starting off, we're going to have our guaranteed branch, the even branch. It's going to be hailstone tree of n times 2. So doubling that value, because that's always going to lead back to n. And we want a height h minus 1 tree from that. And then yeah, so we got that covered. And next up, we have 3 if conditions. And so one condition that we want to check is if n minus 1 over 3 is an integer. So if n minus 1 floor div 3 is equal to mod 3 is equal to 0. So if 3 evenly divides into n minus 1, then we're good to go. And another condition that we might have is that n minus 1 over 3 is an odd number. And so what we're going to do here is going to say like n minus 1 divided by 3. And we're going to make sure it's an odd number. So mod 2, this entire thing, mod 2 is equal to 1. So checking if it's odd. And then, shoot. I'm actually not sure what the last condition you want to check is. Let me think about this real quick. Oh, okay. Yeah, so this is kind of an edge case that you might have not have thought of. But if we consider maybe number 1. And so the thing about this is that 2 leads to 1, but 0 does not. Oh, wait, actually, what am I saying? This is already taken care of with this case right there. I'm actually stuck. Let me check the solution. Okay, this solution is not really necessary. I don't think this condition is actually necessary. And so I'll just paste this in. and we could talk about why it's not needed. So I was originally thinking that maybe, people might say that 0 goes to 1, and so we need to make sure that n minus 1 divided by 3 is greater than 1. Oh, god damn it, you actually need it. Okay, my bad. And so let's consider the number 4. And so there are 2 different ways that we can do this. So 4 could go to 8, and you might also be thinking that 1 could go to 4. But remember, in the case of hailstone, when we see the number 1, we're going to stop right there. All hailstone sequences end with 1. So it couldn't be the case that 1 leads to 4, because 1 is the end of any hailstone sequence, and we're going to stop right there. So because of that, we definitely need to add this condition right here, saying like the number cannot be 1 that we're coming from. And so yeah, so I was being a bit dumb myself, but hopefully that made sense. And yeah, I didn't confuse you or something. But yeah, and so what we're gonna do here is now that we've satisfied all the conditions for whether it could come from an odd number or not, then we're going to add that case right here. So adding that odd tree there. And so it would be n minus 1 floor to 3. So in the case of maybe 16 minus 1 over 3, that gets us to the number 5. And so we're going to pass that number in, and what we also want to do is we also want to decrement the height. So give me a height h minus 1 tree, not a height h tree. And yeah, and at the very end, we're going to return the tree with the current label n, and also the 2 branches or 1 branches that we just made. But yeah, hopefully that made sense, and if you have any questions, feel free to let me know, and I hope you have a great day.